Welcome back. Today, we reframe the problem of Internet Gateway Redundancy, taking real-world conditions into account. We'll explore why this brings more clarity into our choices. Every system has a purpose, and every part of the system, every interconnection, is arranged in order to perform that function. So when we say, I want to be connected to the Internet, if we don't stop to ask why, for whom, what, and under what conditions, then without that visibility into our needs, we might end up solving for the wrong problem entirely. Introduce noise, vibrations, fringe signal conditions, an industrial environment with constant interference. In this setting, your Cat12 cellular failover will perform worse than a simpler Cat4 device. A Cat12 modem, striving to maintain carrier aggregation across multiple channels, introduces jitter, renegotiation events. As it hunts for bandwidth it simply cannot reliably hold. On the other hand, a Cat4 modem, it finds one band, it locks in, it stays connected. Redundancy has specifications. And it is with this consideration in mind that we shall examine the Teltonika RUT240 in this episode. Let's get into it. This is the Teltonika RUT240, and before we configure anything, let's understand the design intent. Let's uncover what Teltonika built and why they built it this way. In the industry, you don't just place things on the desk, they belong in a cabinet, hence the DIN rails. The factory floor conditions generate interference. The aluminum casing provides EMI shielding and thermal dissipation without moving parts. There are vibrations on the factory floor due to the machines. Everything that can get disconnected will, hence a lock-in connector. But this 4-pin connector also has a feature that's missing from most consumer routers. The RUT240 integrates a digital input and an output directly into the power connector. 2 pins power the router, the other 2 connect to the physical world. So the router can react, for example, to a cabinet door switch and send an SMS alert or even trigger a relay remotely. Then there's the choice of hardware components. The Cat4 modem, you already know why. Fringe signal, single band, stays locked. But also it's a simpler design, easier to cool, drawing less power. The 100 Mbps Ethernet, not requiring a fast processor, no thermal load, no throttling. This device is meant to connect machine to machine or to an IoT network. It does not require the throughput to download videos. Industrial protocols require a reliable connection, a predictable one. This is therefore a device built with the intent to work reliably in a hostile environment, because true redundancy begins before the first packet is sent. It begins in the choice of hardware that is fit for the environment in which it will operate. So, what is RutOS? It's a purpose-built, OpenWRT-based Linux distribution designed specifically for Teltonika's hardware. In the previous episode, we saw consumer enthusiast gear designed to prioritize plug-and-play simplicity, hiding complexity in favor of convenience, a good fit for that market. In contrast, RutOS does not hide complexity. It organizes it to provide granular control and stability. It's designed to achieve predictable and reliable operation, repeatable results at scale, presenting a uniform interface across Teltonika's devices. These traits are designed with intent for the harsh industrial environment where configuration mistakes have operational consequences. RutOS is built on a modular architecture, meaning the core system remains lean and secure, while specific industrial functionalities are added as packages. This approach avoids vendor lock-in and ensures that system resources are dedicated only to what's necessary for the mission at hand. Let's have a look at RutOS user interface. On the left, you have 4 sections: status, network, services, and system, each with its own submenus, defined according to the context on top. Basic for ease of use and basic connectivity, and advanced for more nuanced configurations. Across all menus, you will notice on the right-hand side there is a shortcut that pops up where you can easily turn Wi-Fi, RMS, and mobile data on and off. Conceptually, the status section is where all the information on your system is gathered. Starting with overview, where you get a sense of all your connections, system resources, recent events, and remote management system status. Moving on to system, where you get specific product info on your device, your internal modem, the MAC addresses of all your connections. You can dig in further into your connection status in network. On this page, we have all the information on our mobile connection, the signal to noise ratio for the quality of our signal, the reference signal received power, RSRP, which measures the signal strength and is used by the modem to decide where to hand over to a different tower, and the reference signal received quality, how clean the signal is by looking at the ratio of power to total noise interference, RSRQ. Also on cell info, we get all the information we need to what tower we are connected to, and we can check online providers to see its location with respect to ours. Further down on topology, we can scan the wide area network and the LAN to see what connections are available upstream and downstream from our device, something that RMS Connect takes full advantage of. Furthermore, in services, we can look at the running services on this device at this point in time, and in real-time data we can get graphical analysis on any one of the settings we're interested in, for example on the mobile signal over time. This concludes the status section, which is the section which presents information about the state of your device. Now the next three sections are about fine-grained control of the configuration of your device on different levels. In the network section, in the advanced context, you get fine-grained control over all your connections configuration and on the flow of the packages in your system with firewalls, VLANs, routing, DHCP and DNS options. Furthermore, this is where we'll later see how we have fine-grained control over failover options. For example, in the firewall section, all the options of the underlying operating system are exposed, giving you full fine-grained control over default policies, port forwards, traffic rules, NAT rules, attack prevention strategies, and you can even input your own custom rules and assign a DMZ zone. Moreover, you're given the ability to use VLANs to separate a single physical network to multiple isolated networks without separate hardware, giving you the opportunity to separate the management from the services interface without extra hardware. The services section houses all the configuration options that shape the behavior of this device. Once we know what the purpose is, who is going to be using it, what its inputs and outputs are, what it's supposed to do in the system. In essence, when we know the why, for whom, and what, this is where we go to configure it. Cloud Solutions is the submenu in which you configure this device as part of an IoT network, either RMS, remote management system developed by Teltonika on an AWS backbone, or as part of the Azure IoT Hub. I'm adding a video link if you're interested in that. Furthermore, if you wish to encrypt the communications channel, you have all the VPN options and supported protocols in this section. Mobile Utilities enables you to send and receive SMS messages either in a single phone or in a group, changing the behavior of the system or being informed about changes in its state. Input and output subsection is where you configure the physical inputs and outputs in digital I/O as we saw previously. On the industry floor, you would expect the RUT240 to be connected to a machine. And in the services section, you would be configuring the service which connects to that machine, be it MQTT, OPC UA, Modbus, or whichever other way is supported. Then in the data to server submenu, you can configure data senders, where you gather all this data up and send it to a remote server over an encrypted connection. Finally, in event reporting, you can configure under what conditions the device informs you, either via email or SMS, on changes in its state. For example, here we've set up an event to inform us of any topology changes via a message to our mobile number. Although it's the last section we're looking at, the system section is where you would initially go to set up your device, choose the package functionality you need, and harden the system before deployment. Initially, you'd go through the setup wizard to set up all your connections and connect to the RMS. Then you'd go to the firmware section to make sure you're up on the latest firmware. Teltonika Networks is a partner in the CVE program, where they identify, define, and catalog publicly disclosed cybersecurity vulnerabilities, so they keep their firmware up to date and have pages for each device with the latest firmware posted. We can then define the extra functionality we want for our system in Package Manager. For example, here we have Azure IoT Hub installed, but we can also check for MQTT, Modbus, OPC UA, and according to our needs, install the functionality we require. These are not just OpenWRT packages, but they're also packages developed and curated by Teltonika Networks themselves. So there is extra functionality here with respect to the vanillas OpenWRT systems. We can then move on to maintenance, where we have the ability to set up watch timers to reboot the device or the modem, depending on the situation. Decide under what conditions this happens, either by pinging specific addresses or trying to get specific websites with wget. Furthermore, we can troubleshoot the system and also have direct access on the CLI within your UI without needing to go to a terminal. Moreover, we can even see the event logs, where we can check system events, network events, connection events, and even startup scripts. Finally, we can get into administration, where we can set up general settings like the language we use, the default context, the device name and host name, whether the indicators are up, even how the reset button performs depending on the time during which you press it. Then we can set up date and time and make sure the device synchronized on NTP servers, change the password and add even more users on the device for specific administration needs, handle access control, hardening the device as we saw in previous videos by enabling or disabling services on the WAN and the LAN. We can specifically add groups that receive messages from the device and also add the emails of administrators, handle certificates directly from the device, and what is very, very useful, we can add configuration profiles, setting up the device for different performance options. For example, you can set less data use during the nighttime, and you can schedule it here. But what does RutOS have to do with our discussion on Internet Gateway Redundancy? The answer is that having the hardware that's designed for purpose doesn't do much good if the software can take advantage of it. Also, redundancy has larger scope in the context of predictable behavior and reliability. That is, when something fails, someone must get notified with enough context to make this information actionable. Furthermore, when something fails completely, something must already be in place to take up the slack. And for such deployments to be effective, both the hardware and the software must support these features. As an example here, myserver.com receives data from my device, which I've set up on data to server. I therefore only want to switch over to another connection if connecting to myserver.com fails. To do it by ping on the IP address does not ensure that the systems work correctly. Only wget can ensure that I can reach my services, so I set up my one connection to check for that and failover only when that fails. Now, once I receive a failover event by SMS, I can log into my router, check the logs, check troubleshooting, and see what happened. And how would I handle this if it's essential machinery and I'm very far away and the device has completely failed? In such a case, I would have set virtual router redundancy protocol installed via packages on my device. I would have defined a cluster of two identical devices with one master and one slave. And once the device failed, the protocol will switch over to the other identical device, maintaining connectivity without problems. That's what redundancy means in the industrial setting. This brings us back to the point that redundancy has specifications. And to reach those specifications, you have to understand your needs. You have to have a framework to analyze and test. Please let me know your thoughts in the comments on what redundancy means for you in the context of internet gateways. The next chapter, we'll have a look at RMS and see how we manage things at scale. Teltonika RMS is a centralized, cloud-based platform hosted on AWS, specifically designed to manage and monitor distributed IoT infrastructure at scale. A primary architectural decision is the use of secure encrypted tunnel established via hard-coded OpenVPN connection that allows bidirectional communication between the cloud and the device without requiring public IP addresses. The system relies on the MQTT protocol and is secured with TLS 1.2 and 1.3 encryption to ensure the highest standards of safety for mission-critical industrial applications. Furthermore, the architecture is modular, separating services into management, connect, VPN, and API components to allow users to pay only for the specific functionalities they require, either in credits or in packages. The main functionalities of the system are RMS management, RMS Connect, RMS VPN, and RMS API. The RMS management feature provides full control over entire fleets of Teltonika devices, enabling real-time health monitoring and the ability to push bulk firmware updates simultaneously. It acts as a single pane of glass interface for administrators to supervise thousands of sites and receive custom alerts for events like signal drops or GPS boundary crossings. On the other hand, the RMS Connect system enables users to reach and control non-Teltonika smart devices like PLCs, industrial PCs, or IP cameras located behind the router via RDP, VNC, SSH, or HTTPS. By allowing remote management beyond the router, it eliminates the need for expensive on-site maintenance visits to troubleshoot third-party equipment. Then, RMS VPN. The functionality simplifies the creation of encrypted VPN tunnels to an entire network infrastructure, allowing for secure simultaneous access to multiple endpoints. It is designed to be highly efficient for large-scale networks, removing the complexity of manual server configurations and diverse protocol setups. Finally, the RMS API allows companies to integrate specific RMS functionalities directly into their existing in-house IoT or SCADA platforms. By utilizing this API, operators can maintain the familiar interfaces while gaining their back-end visibility and control provided by the RMS ecosystem. Today, we had the opportunity to discuss the RUT240 by Teltonika Networks, both as a device, but also as a way to explore an ecosystem specific to a unique set of requirements. We set up a simple framework to define our needs with answers to specific questions. Why? Because we need operational continuity in an environment where downtime has consequences. For whom? The industrial operator, the OT engineer, the systems integrator. What? A router that is physically and logically specified for the environment. And under what conditions? Fringe signal, EMI, vibration, heat, remote location. But more than that, we had the ability to reframe the question of redundancy, which we are exploring in this series, in the greater context of reliability, of predictable operation, and of the tools required to handle this both on a single device, where we set up failover using wget to bypass ISP false positive pings, but also looked at LAN-side gateway redundancy using virtual router redundancy protocol, and also at scale, as part of an IoT platform designed to handle that scale, using the RMS by Teltonika Networks. I hope you enjoyed the discussion. I encourage your comments on length, depth, and focus of this series. Please check the provided links and suggested videos in the description. I thank you for your time. I hope to catch you in the next one.